Hey team, it's Mr. Z, and today we're going to cover everyone's favorite part of math, the application word problems that require you to draw a picture to make sense of a situation. It isn't that bad, folks. Let's try to do a couple together. All right, so you're going to be given a situation, and they're going to give you just enough information to get an answer. But always, let's go ahead and draw a picture. So when we're assuming that there is a graph, and it says that Mike shoots an arrow from an initial height of 2 meters. So I just drew a small XY axis to kind of illustrate. Most of what we're going to be doing is going to be focused in quadrant 1. The reason being is that's where the X and the Y values are both positive. So basically, I want you to use 0, 0 as your starter point to kind of build a picture. This is just ground level and the start. So when it says Mike shoots an arrow from an initial height of 2 meters, right? So that means this guy Mike is here at an initial height of 2 meters. This means it's a y-intercept, and a y-intercept will always have the value 0 to the left and right, and then 2. So this is where Mike is going. Let me draw Mike. Mike is over here, and he's shooting an arrow, and he's going to shoot it from an initial height of 2 meters. This arrow is going to shoot. Now think of what happens when you shoot an arrow. It goes like something like a parabola, right? Now this is just a sketch, but that's essentially the idea. I'm going to draw a better one just because I know that it is concave down. It's going to have a maximum is the idea. The arrow is going to hit this point in the sky where it's at its highest, and then it's going to descend slowly to the ground. The arrow reaches its maximum height after it has flown 60 meters, height of 20 meters. This height of 20 meters means it's going to be the y value, and a distance is going to be the x distance. So essentially what's happening is from here to here is 60 meters. And how high is it? 20 meters, making this point to be 60, 20. What have we been given? We have been given the vertex, which is 60, 20, HK. And we've been also given a point, which is 0, 2, which is the x and f of x values. I think I know where I'm going to go here. I'm going to choose to use vertex form of f of x is going to be equal to a times x minus h squared plus k. I'm going to go ahead and substitute some values in. The f of x value is going to be 2. The x value is 0. I'm going to substitute in for h is 60 and k is 20. Now I need to make sure it matches the formula exactly. 2 is equal to a x minus 60 squared plus 20. Let me go ahead and resolve this. 2 is equal to a times negative 60 squared plus 20. Negative 6 times negative 6 is positive 36. So I know this is going to be 336 with 2 zeros. 2 is equal to 3,600a plus 20. I'm going to subtract 18 from both sides, or 20 from both sides, leading to 18. I'm a step ahead. And I'm left with 3,600a. I divide each side by 3,600. And I'm going to get an a value that is equal to negative 18 over 3,600. Now, 18 and 36 are all divisible by 3, and even more so, they're divisible by 9. So I'm going to reduce this by dividing the numerator and denominator by 9, leading to negative 2. 36 divided by 9 is 4 with 2 zeros. I'm going to reduce this again. I see a 2 and a 4. It's going to turn into a is equal to negative 1 over 200. I'm going to take a moment and analyze. Did my a value match my situation? Is my graph actually concave down? The answer is yes. Yes, it is. I had to simplify my a value a couple of times, but using inverses, I was able to generate it based on the criteria of the situation. And notice how it's a weird fraction. That's often the case when applications. You guys are so used to dealing with natural numbers, but more often than not, the world is going to have fractional values for everything. So the last thing I need to do is do this equation for Mike's arrow, and it's going to be f of x is equal to negative 1 over 200 x minus the h value, which is 60, squared plus 20. Voila! This is going to document the travel of Mike's arrow as it goes from an initial value of 0 to. Number 2. Max hits a baseball tree off of a tee that is 3 feet high. The ball reaches a maximum height of 20 feet when it is 15 feet from the tee. So very similar. He has a tee that is 3 feet high. This is 0, 3. He's going to hit that baseball, and it's going to go whoosh. It's going to go up, and it's going to fall back down. It is going to be a maximum. So where is that maximum? It's at a maximum height of 20. The height represents the y value. So I know it's going to be 15 feet, comma, 20. Again, I'm giving vertex form. So I'm going to go ahead and replace my values. F of x is equal to a times x minus h squared plus k. I'm going to go ahead and plug in some stuff. I'm going to plug in 3 is equal to a times, what is my x value? Okay, looking, it's a 0 minus 15. Let me be consistent with my colors. Squared plus k value is 20. If it helps you, you can go ahead and make a key. You can say h is 15, k is 20, x is 0, f of x is 3. Whatever you need to be successful. Then comes the autopilot where you're processing. I know that negative 15 squared is going to be 225 plus 20. Notice I always take a moment to rewrite the coefficient in front. I'm going to minus 20 from both sides. And I'm going to get negative 17 is equal to 225a. I hope you know where this is going. And I get a is equal to negative 17 over 225. I know this number can't be reduced. 17 is prime. The last thing I need to check is think. All right, this graph looks concave down. Is the a value I generated concave down? And yes, it is. It's negative. So that being said, that's good enough for my soul. I'm going to go ahead and rewrite my function with my new a value that I worked so hard to generate. And then I'm going to have x minus h, 15 squared plus 20. Leave it like that. That is the equation for Max's baseball skills for that particular hit. All right, number 3, let's set up the pitcher. The Amazing Larry is a human cannonball. He would like to reach a maximum height from launch. So if he has a cannon and he is shooting, he wants to reach a maximum height of 30 feet. The height being 30. Based on his Amazing Larry's previous launches, his assistant has estimated that this will occur when he is 40 feet from the cannon. 40 feet from the cannon. 40 feet away from the cannon. When he's shot from the cannon, he is 10 feet above the ground. So this initial value is going to be 10 feet above the ground. The starting value is 0, 10 feet up vertically. Now go ahead, find the A value, and go ahead and write out your equation. I hope this helps. Remember, it's not that intimidating. Just remember, what are we studying? Quadratics. So my picture should resemble a quadratic. Hint, hint, nudge, nudge. Have a great day.